Hello students, in our previous class we learned about polynomials. What is polynomials and what is the degree of a polynomial and types of polynomials like linear, quadratic, etc. Okay, and we also learned how we can find the value of a polynomial at a particular point. Okay, in this class we will learn what do you mean by zero of a polynomial. Okay, so what do you mean by zero of a polynomial? Zero of a polynomial is or are that or those value or values of the variable for which that polynomial becomes zero. Okay, so what do you mean by zero of a polynomial? Zero or root of a polynomial is or are that or those value or values of the variable for which that polynomial becomes zero. As an example, if f of x equals to 3x minus 3, then for x equals to 1, we have f of 1 is equals to 3 into 1 minus 3, that is 3 minus 3 equals to 0, imply 1 is the 0 of the polynomial f of x. Okay, here we consider a polynomial f of x that is equals to 3x minus 3. Then we see for x equals to 1, we have f of 1 equals to 0. That indicates 1 is the 0 or root of this polynomial f of x. Okay. Now we take example 2. F of x equals to x square minus 3x plus 2. Here for x equals to 1, f of 1 is equals to 1 square minus 3 into 1 plus 2, that is 1 minus 3 plus 2, that is equals to 0. And for x equals to 2, f of 2 is equals to 2 square minus 3 into 2 plus 2. That is equals to 4 minus 6 plus 2, that is also equals to 0. Implies that 1 and 2 are the zeros of the polynomial f of x. Okay. In the second example, we consider a quadratic polynomial x square f of x equals to x square minus 3x plus 2. So here for x equals to 1, we have f of 1 is equals to 0, and for x equals to 2, f of 2 is also equals to 0. That indicates 1 and 2 are the zeros of this quadratic polynomial f of x. Okay. Now, if we have to check a polynomial for different kinds of particular points, which may give the zeros of the polynomial or not. Okay, that means suppose we have example 3. If f of x equals to x cube minus 3x square plus 3x minus 1, then check x equal 1 and 2 are the zeros of the polynomial f of x or not. That means we have to check for this polynomial f of x equals to x cube minus 3x square plus 3x minus 1, 1 and 2 may be its zeros or not. Okay. So, to check this solution, to check this, we have to find f of 1 and f of 2. If f of 1 equals to 0 and f of 2 equals to 0, then we can say one and 2 are the zeros of the polynomial f of x. Okay. Now, f of 1 is equals to 1 cube minus 3 into 1 square plus 3 into 1 minus 1, that is 1 minus 3 plus 3 minus 1 equals to 0, and f of 2 is equals to 2 cube minus 3 into 2 square plus 3 into 2 minus 1 equals to 8 minus 12 plus 6 minus 1. 8 plus 6, 14, 14 minus 13, 1 not equals to 0, imply 1 is the zero of the polynomial f of x, but 2 is not the zero of the polynomial f of x. Okay. So, here we consider a polynomial f of x equals to x cube minus 3x square plus 3x minus 1. Then, at these two different values of the variable x, 1 and 2, we have to check 1 and 2 are the zeros of this polynomial f of x or not. So, to check this, we have to find f of 1 and f of 2. So, if f of 1 equals to 0 and f of 2 equals to 0, then we can say a1 and 2 are the zeros of this polynomial f of x. Okay, that is why we find f of 1 and then f of 2. F of 1 becomes 0 and f of 2 is not equals to 0. That is why we can say 1 is the 0 of this polynomial f of x, but 2 is not the 0 of this polynomial f of x. Now we will learn how we can find the zeros of any kind of polynomial. Okay, so to find the zeros of any kind of polynomial, we have to know about two special theorems which are known as integral root theorem and another is rational root theorem. Okay, let's see what those theorems states. Integral root theorem. If the coefficient of the leading term of a polynomial is 1, then sum of the factors of the constant term of that polynomial will be the zeros of that polynomial. Okay, so integral root theorem states that if the coefficient of the leading term of a polynomial is 1, then sum of the factors of the constant term of that polynomial will be the zeros of that polynomial. Okay, so what is leading term? Leading term of a polynomial is the highest degree term. Okay, so leading term means the highest degree term of a polynomial. Okay, as an example, we take example 1. F of x equals to x cube plus 2x square. So here we consider a polynomial f of x equals to x cube plus 2x square minus 11x minus 2. Here, here we consider a polynomial f of x equals to x cube plus 2x square minus 11x minus 12. We have to find the zeros of this polynomial with the help of integral root theorem. Okay, if we follow this polynomial, then its highest degree term is x cube. So leading term is x cube and its coefficient is 1. Okay, so here we can easily apply this integral root theorem. Here the leading term is x cube and its coefficient is 1. Okay. So we can apply integral root theorem to find the zeros of this polynomial f of x. Here the constant term is minus 12. Factors of minus 12 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. Okay. So in this polynomial f of x equals to x cube plus 2x square minus 11x minus 12, the leading term is x cube and its coefficient is 1. So we can apply integral root theorem. So to find the zeros of this polynomial f of x. Okay. So here the constant term is minus 12 and the factors of minus 12 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6 and plus minus 12. So now f of 1 is equals to 1 cube plus 2 into 1 square minus 11 into 1 minus 12, that is 1 plus 2 minus 11 minus 12, that is 23 minus 3, that is minus 20, not equals to 0. F of minus 1 minus 1 plus 2 plus 11 minus 12, that is 13 minus 13 equals to 0. Okay, f of 1 will give minus 20 and f of minus 1 will give 0. F of 3 is equals to 3 cube plus 2 into 3 square minus 11 into 3 minus 12, that is 27 plus 18 minus 33 minus 12, that is 45 minus 45 equals to 0. F of 4 equals to 4 cube plus 2 into 4 square minus 11 into 4 minus 12, that is 64 plus 32 minus 44 minus 12, which will give 96 minus 56, that is 36, 96, sorry, 96 minus 56, that is 40, not equals to 0. F of minus 4 is equals to minus 4 whole cube plus 2 into minus 4 whole square minus 11 into minus 4 minus 12, that is minus 64 plus 32 plus 44 minus 12. This will give 76 minus 76. This will give 0. So this imply minus 1, 3 and minus 4. Minus 1, 3 and minus 4 are the zeros of f of x by integral root theorem. Okay.